The Multiverse Employee Handbook has this to say about the Alpha Centauri system. It is, in theory, the cosmic neighbor we should know best, a tidy trinary star system just over 4 light-years away, practically the next door down in galactic terms. And yet, despite its close proximity, Alpha Centauri remains less a familiar friend and more a distant celebrity. We insist we've met at a conference, but definitely haven't. The system consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and the smaller, more mysterious Proxima Centauri, which orbits the pair like a socially awkward third wheel. Together they form the gravitational equivalent of a complicated group chat, technically connected, occasionally flaring up, and nearly impossible to observe without confusion. What makes Alpha Centauri especially noteworthy is not just its closeness, but our relentless projection onto it. Humanity has spent decades imagining it as the place we'll go next, a sort of cosmic escape plan in case Earth finally decides to cash out. We don't really know what's there, but we've already emotionally invested in it. It's the astronomical equivalent of falling in love with someone because their LinkedIn profile says open to relocation. The handbook notes that this hopeful enthusiasm is not entirely backed by data, beyond a few basic statistics, mass, temperature, and the occasional planetary maybe. We remain bafflingly ignorant of our nearest stellar companions. This has resulted in what astrosociologists call neighborhood awkwardness on a galactic scale, in which we gaze longingly across the void, while knowing roughly as much about Alpha Centauri as we do about the internal policies of Neptune. It's the uncomfortable reality of living in a cosmic cul-de-sac, surrounded by intriguing addresses, but no one ever comes out for a proper street party. You're tuned into the Multiverse Employee Handbook. Today we're exploring the Alpha Centauri system, our nearest stellar neighbors, a mere 4.37 light-years away. That's close enough to be theoretically encouraging and far enough to be functionally devastating, like discovering your company's satellite office is technically nearby, but requires a 4-century commute each way. We're talking about a triple-star system that humanity has collectively designated as Plan B for civilization, despite knowing approximately as much about it as we know about the contents of Karen's locked filing cabinet in accounting, which is to say, not much, but we're deeply invested anyway. We'll examine the gravitational choreography of 2 sun-like stars locked in an 80-year tango, while a temperamental red dwarf judges them from thousands of astronomical units away. We'll discuss planets that exist in so-called habitable zones, a term that, as we'll discover, carries roughly the same guarantee as entry-level position with room for growth. And we'll explore why the closest thing to us in the entire galaxy still feels more like a celebrity we've never actually met than a neighbor we could reasonably borrow a cup of antimatter from. This is a story about proximity without accessibility, optimism without data, and the very human tendency to fall in love with a LinkedIn profile that says open to relocation, while ignoring the section that mentions requires atmosphere not being stripped away by constant stellar radiation. But first, gather round the Habitable Zone Planning Committee, my radiation-hardened resource allocators, for a tale that would make even the most optimistic exoplanet researcher reconsider their career in celestial real estate. in the fluorescent-lit realm of quantum improbability solutions, specifically in the Employee Family Services Division, which existed in a superposition of technically provided and perpetually underfunded. Director Patricia Vendros was having what could charitably be called an infrastructure vaporization crisis. It had started, as these things often do, with an executive memo that radiated enthusiasm in inverse proportion to its grasp of astrophysics. Subject: exciting family-friendly initiative. Proxima facility opening. From the square-haired boss. Team: thrilled to announce we're opening QIS's first interstellar childcare facility on Proxima Centauri b. As you know, this planet sits squarely in the habitable zone, making it the perfect family-friendly location for our expanding Proxima Division workforce. Grand opening, next fiscal quarter. Patricia had stared at this memo for what felt like several geological epochs. She pulled up the site survey for Proxima Centauri b, written by engineers rather than executives. Proxima Centauri b site assessment. Technically inhabitable zone. Yes, actually habitable. Long pause. Stellar flare frequency. Often. X-ray/UV radiation levels 60 times Earth normal. Recommendation: suitable for equipment storage, provided equipment is expendable and ideally non-flammable. Patricia forwarded the survey with carefully worded phrases like thermal concerns and atmospheric considerations. The response came 17 minutes later. Great. So we're good to proceed. Please ensure playground equipment is fire-resistant. The Proxima Centauri b childcare facility and learning center opened on schedule, which is to say 3 months late and 40% over budget. For exactly 6 hours and 14 minutes, it was a triumph of corporate optimism over astrophysical reality. Then Proxima Centauri did what Proxima Centauri does roughly once a day. It flared. A massive burst of X-rays and charged particles swept across the planet's surface. The specially ordered fire-resistant swing set, which had cost more than the entire Earth-based playground budget for the previous fiscal year, lasted approximately 14 seconds before achieving what the incident report would later describe as spontaneous thermal disassembly. The slide melted into an avant-garde sculpture. Some on the facilities committee argued it should be preserved as a teaching moment. This debate became moot 36 hours later, when another flare reduced it to vapor. Patricia's inbox filled with increasingly desperate messages. The swings are gone again. Also, the sandbox has fused into glass. Should I order replacements? This is the 4th swing set requisition this month. Is there a bulk discount we should be negotiating? Patricia, we're showing playground equipment replacement costs at 847% of projection. Please advise. Patricia advised. She advised extensively, in emails, in reports, in presentations featuring graphs that resembled seismograph readouts from a major earthquake. She advised that perhaps, and this was just a thought, operating a childcare facility on a planet experiencing regular radiation bursts, intense enough to sterilize a small moon, might not be ideal. The response was admirably consistent. But it's in the habitable zone. This phrase possessed a near-magical ability to end conversations. It was deployed like a corporate incantation, a ward against inconvenient follow-up questions. The planet was in the habitable zone, therefore it was habitable. Therefore the facility would remain open. Therefore she should order more swing sets. By the end of the first quarter, the Proxima facility's procurement budget had exceeded that of the entire Earth-Moon logistics network. The swing sets arrived in bulk shipments, each tagged with an estimated lifespan ranging from optimistic hours to pessimistic minutes. It was Karen from accounting who finally noticed. Karen, whose job was to notice things that didn't add up, had been reviewing quarterly expenditures when she encountered a line item so improbable she assumed it was a data entry error. Proxima facility, playground equipment replacement, 47 million credits. She cross-referenced this against other facilities. The entire Mars division, serving 4,000 employees and their families, had spent 180,000 credits on playground maintenance for the year. The Proxima facility served 17 families. Karen scheduled a meeting. She brought graphs. "We're spending," Karen said, with the measured calm of someone who had transcended shock and arrived at a kind of fiscal zen, "more on swing sets for one facility than we spend on the entire Jovian Station's life support system." The square-haired boss nodded thoughtfully. "But the planet is in the habitable zone. The swing sets are being vaporized by stellar radiation, weekly, sometimes daily. Fire-resistant swing sets. They're resistant to fire," Karen said, "not to the surface of a star being flung at them at relativistic speeds." The audit came 2 weeks later. The investigator's report was brief. Finding: the Proxima Centauri B facility has the highest equipment replacement cost in company history. Cause: facility is located on a planet that, while technically in the habitable zone, is regularly bathed in enough high-energy radiation to destroy a medium-sized playground. Additional note: the phrase habitable zone should not be interpreted as habitable without significant additional qualifiers. The facility remained open. The square-haired boss explained that closing it would send the wrong message about the company's commitment to family services. Instead, they rebranded it as the Proxima Extreme Environment Learning Center and added a line to the employee handbook. "Parents utilizing the Proxima facility should be aware that outdoor equipment lifespan may vary due to local stellar weather conditions." They also negotiated a bulk discount with the swing set supplier. Patricia received a commendation for creative resource management in challenging astrophysical conditions. And somewhere in the vast accounting databases of quantum improbability solutions, a line item continued to grow, quarter after quarter, a monument to the critical difference between in the habitable zone and actually habitable, a distinction that had cost roughly the GDP of a small moon. The swing set shipments continued. Proxima Centauri flared. The universe, indifferent to corporate policy, carried on. And that brings us to the fascinating science behind the Alpha Centauri system, and more specifically, the treacherous gap between close enough to visit and worth visiting once you get there. Unlike Star Trek's vision of Alpha Centauri as a bustling hub of interstellar civilization, this triple-star system is more accurately described as a complicated family arrangement we've been staring at longingly for centuries while knowing approximately nothing useful about it. The system consists of 3 stars engaged in what physicists call a gravitationally bound system, and what anyone else would call an 80-year argument with a heckler in the distance. Alpha Centauri A and B, 2 relatively normal stars not unlike our own Sun, orbit each other every 79.8 years in an elliptical dance that brings them as close as 11 astronomical units and as far as 36 AU apart. That's roughly the difference between Saturn's orbit and Neptune's orbit, if you're keeping score at home, which suggests they value their personal space. Then there's Proxima Centauri, the red dwarf, technically Alpha Centauri C, though it prefers to maintain a distance of about 13,000 astronomical units from its companions, which in stellar terms is the equivalent of attending family reunions by video conference from another country. What makes this system particularly noteworthy is not just that it's our nearest stellar neighbor at 4.37 light-years, a distance that sounds encouragingly small until you remember light travels at 300,000 kilometers per second and still needs over 4 years to cover it. No, what makes Alpha Centauri fascinating is that we've discovered planets there, actual planets, orbiting actual stars, in what we optimistically call habitable zones. As Patricia from Facilities Management has just demonstrated, the phrase habitable zone is doing a tremendous amount of work in that sentence. Work it is not entirely qualified to perform. When we return from this brief quantum fluctuation, we'll dive deeper into what we actually know about these planets, why Proxima Centauri's temper tantrums make it a challenging place to maintain playground equipment or, indeed, atmospheres, and explore whether the more sedate A and B components offer any hope for those of us dreaming of corporate expansion beyond the Sol system. We'll also examine the three-body problem, not as abstract mathematics, but as the organizational nightmare of trying to establish stable working conditions when you've got 3 stars all pulling in different directions and filing separate timesheets. Welcome back, my stellarly challenged procurement specialists. Alpha Centauri is what astronomers call a hierarchical triple system, and what anyone managing a corporate org chart would call a reporting structure nightmare. At the center of this arrangement are Alpha Centauri A and B, 2 stars locked in a 79.8-year orbital partnership that can only be described as committed, if somewhat elliptical. Alpha Centauri A is a G-type star, almost identical to our Sun, about 1.1 solar masses, slightly brighter, the kind of star that would put team player on its LinkedIn profile. Alpha Centauri B is a K-type star, cooler and dimmer at about 0.9 solar masses, the slightly less ambitious sibling who's perfectly content with middle management. These two orbit each other at distances ranging from about 11 to 36 astronomical units. That's the span from Saturn to beyond Neptune, if we're using our own solar system as reference. Their orbit is notably eccentric, with an eccentricity of 0.52, meaning they don't circle each other in a neat, predictable pattern, but rather in an elongated ellipse that suggests they occasionally need space but ultimately can't quit each other. The orbital period of 79.8 years means that if you'd started observing them during World War II, you'd only just now be seeing them return to the same relative position. Then there's Proxima Centauri. Proxima orbits the AB pair at a distance of roughly 13,000 astronomical units, about 1/5 of a light year, which in stellar terms is the equivalent of living in the same city, but definitely not the same neighborhood. It's gravitationally bound to the system, we're fairly sure, though its orbital period is estimated at 550,000 years, which means no human civilization has ever observed a complete orbit and none ever will. Proxima is an M-class red dwarf, small, cool, dim, and prone to spectacular outbursts of temper in the form of stellar flares. If Alpha Centauri A is the stable corporate executive and B is the dependable middle manager, Proxima is the volatile employee everyone tiptoes around because you never know when they're going to have an incident that requires HR intervention and possibly facility-wide evacuation. Now, humans didn't always know Alpha Centauri was a triple system. We didn't even know it was a double system until 1689, when a French Jesuit astronomer named Jean Richaud was observing a comet from Puducherry, India, and happened to notice, almost by accident, that what everyone assumed was a single bright star was actually 2 stars extremely close together. This is the astronomical equivalent of showing up to a meeting you thought was with one person and discovering it's actually with 2 people who've been sitting so close together you didn't notice. Richaud, to his credit, documented this and moved on, presumably to observe his comet, because comets had deadlines and binary stars did not. For the next century and a half, Alpha Centauri remained a curiosity. Two bright stars, probably close to each other in space. Definitely close to each other in the sky, but with no clear sense of how far away they actually were. This changed between 1832 and 1839, when Thomas Henderson, a Scottish astronomer working at the Cape of Good Hope, made the first successful parallax measurements of Alpha Centauri. Parallax, for those unfamiliar with the concept, is the apparent shift in position of an object when viewed from two different locations. Hold your finger up in front of your face and close one eye, then the other. Your finger appears to move against the background. Do the same thing with a star using Earth's position on opposite sides of its orbit as your two viewing locations, and you can calculate how far away the star is. Henderson's measurements revealed that Alpha Centauri was just over 4 light-years away, the closest star system to our Sun. This was a momentous discovery, though Henderson, in a fit of what can only be described as astronomical self-doubt, sat on his data for years before publishing it, worried he'd made an error. By the time he finally went public, Friedrich Bessel had beaten him to the punch by measuring the parallax of a different star, 61 Cygni. Henderson thus achieved the academic equivalent of completing a project on time, but not submitting it until after the deadline, then wondering why someone else got credit. It's a cautionary tale about the importance of filing your reports promptly, even across interstellar distances. But the Alpha Centauri story wasn't done. In 1915, Robert Innes, director of the Union Observatory in South Africa, discovered a third star, a faint red dwarf that appeared to be moving through space at the same rate and direction as Alpha Centauri A and B. This was Proxima Centauri, so named because it was, and is, the closest star to Earth at 4.2465 light-years. Proxima is so dim, about 17,000 times fainter than the Sun, that despite being our nearest stellar neighbor, you cannot see it with the naked eye. It's visible magnitude 11, which requires a decent telescope and some patience. This is the stellar equivalent of having a next-door neighbor so quiet you forget they exist until they occasionally set off fireworks at 2 a.m., by which we mean stellar flares that would make Earth's solar storms look like a polite cough. From a corporate management perspective, the Alpha Centauri system is an organizational consultant's nightmare. You have two primary offices, A and B, locked in an orbital partnership that takes 80 years to complete one full cycle, with separation distances that vary by a factor of 3. Try syncing your fiscal quarters across that kind of timeline. Then you have a third office, Proxima, so far removed from the main operation that communications lag alone would take months. Assuming you could get a clear signal past Proxima's tendency to randomly emit bursts of electromagnetic radiation that would fry anything not heavily shielded. This is what physicists call the three-body problem, and what anyone who's ever worked in a matrixed organization calls Monday. The three-body problem, formally speaking, is the challenge of predicting the motion of three gravitating bodies. Two bodies, like Earth and the Sun, are simple. The math is elegant, the orbits are predictable. Newton solved it centuries ago. Add a third body, and suddenly you're dealing with chaos theory, sensitive dependence on initial conditions, and the uncomfortable realization that some systems simply cannot be solved with a neat equation. You can simulate them. You can approximate them. You can throw computers at them until you get something that looks right for a few million years. but you cannot solve them in the way you can solve a two-body system, with a beautiful formula that tells you exactly where everything will be at any given time. This feels philosophically like an appropriate metaphor for corporate life, for family dynamics, for any situation where you've got three entities all pulling on each other and nobody's quite sure who's in charge. Are Alpha Centauri A and B the primary system, with Proxima as a distant subsidiary? Or is Proxima an independent operator that just happens to be gravitationally entangled with the pair? The math doesn't care about organizational hierarchy. The stars orbit according to the forces acting on them, indifferent to our need for clear reporting structures. And perhaps that's the uncomfortable truth hiding in the Alpha Centauri system, that we're all just bodies in motion, responding to forces we can't fully control, locked in orbits we didn't choose, but can't escape. Some of us are in tight binaries, circling the same concerns every 80 years. Others are distant companions, technically part of the system but practically isolated, checking in every 500,000 years to see if anything's changed. The stars don't struggle with this. They don't schedule meetings or send memos or worry about alignment. They just orbit, pulled by gravity, indifferent to meaning. We, on the other hand, build childcare facilities in habitable zones and wonder why the universe keeps vaporizing our swing sets. Now, let's talk about what might actually be orbiting these stars, because this is where our story of proximity and disappointment truly achieves its full cosmic potential. In 2016, the European Southern Observatory announced the discovery of Proxima Centauri b, a planet with a minimum mass of about 1.17 Earth masses, orbiting in what scientists cheerfully described as the habitable zone. The headlines were optimistic. Humanity collectively decided we'd found our backup plan. Then people actually looked at the data. Proxima b orbits its star every 11.2 days at a distance just under 0.05 of an astronomical unit. That's about 7.3 million kilometers, or roughly 1/8 the distance between Mercury and our Sun. For a planet around a normal Sun-like star, this would be a death sentence, a scorched hellscape where lead would pool in lakes. But Proxima Centauri is a red dwarf, cool and dim, outputting only about 0.0017 times the Sun's luminosity. At 0.049 astronomical units, Proxima b receives roughly the same amount of total energy Earth gets from the Sun. This is what astronomers mean by habitable zone, the region where a planet receives enough starlight to potentially maintain liquid water on its surface, assuming it has a surface and an atmosphere, and isn't being actively sterilized by its host star's violent mood swings. Because here's what the habitable zone calculation doesn't account for. Proxima Centauri is what we might diplomatically call temperamental. Red dwarfs in general are prone to stellar flares, sudden, intense bursts of electromagnetic radiation and charged particles. Proxima, even by red dwarf standards, is excessive. It regularly unleashes flares that increase its brightness by factors of 10 or more, bombarding anything nearby with X-rays and ultraviolet radiation at levels 10 to 60 times what Earth receives from the Sun. This is the astrophysical equivalent of renting office space in a building with excellent square footage and natural lighting, then discovering the natural lighting comes from a landlord who periodically sets fire to the lobby. Technically habitable? Perhaps. Practically livable? Debatable. Now, Proxima b likely has other problems beyond the regular radiation baths. At such a close orbital distance, the planet is almost certainly tidally locked, meaning one side permanently faces the star while the other faces eternal darkness. This is the same configuration as our moon relative to Earth. One hemisphere experiences endless searing day, the other endless frozen night. Any atmosphere would need to redistribute heat from the day side to the night side, or you'd end up with one side hot enough to vaporize oceans and the other side cold enough to freeze the atmosphere itself into snow. Climate models suggest this might be possible. With the right atmospheric composition, the right amount of ocean coverage, the right rotational configuration, you could potentially have temperate zones near the terminator, the boundary between day and night. Life could theoretically exist in a narrow habitable band, huddling between the too hot and the too cold, like employees clustering near the office thermostat set at competing temperatures by warring departments. But then there's the atmospheric erosion problem. Proxima Centauri's stellar wind, the stream of charged particles flowing from the star, is estimated to be about 8 times more intense than the solar wind at Earth. Combined with those frequent flares and the lack of a protective magnetic field, we don't know if Proxima b has one. But given its likely formation history, it's not guaranteed. You're looking at a planet that may be losing its atmosphere to space faster than geological processes can replenish it. This is Patricia's swing set problem on a planetary scale. You can keep replacing the atmosphere, keep replenishing the oceans through volcanic outgassing and comet delivery. But if the star keeps vaporizing everything you install, eventually even the most optimistic facilities manager has to admit this might not be the ideal location. Proxima's planetary system has other members. In 2022, astronomers announced Proxima d, a planet with an estimated mass of about 0.26 Earth masses, orbiting every 5.1 days at a distance that makes Proxima b look comfortably distant by comparison. Proxima d is not in the habitable zone. Proxima d is not pretending to be in the habitable zone. Proxima d is the planetary equivalent of a storage closet, someone optimistically labeled office space on the floor plan. It's there, it technically orbits the star, and that's about all we can say in its favor. There's also a potential third planet, Proxima c, which some observations suggest might exist in a longer orbit. But its status remains disputed, existing in a superposition of probably there and possibly a data artifact, which in astronomical terms means we're still arguing about it in conference rooms. Now, what about Alpha Centauri A and B, the more sedate members of the system? Surely they, with their sun-like characteristics and lack of violent outbursts, must have planets? We don't know. Despite decades of searching, despite telescopes of increasing sensitivity, despite radial velocity surveys that should have detected Jupiter-mass planets easily and Earth-mass planets eventually, we've found nothing confirmed around either star. Well, almost nothing. In 2021, the Very Large Telescope's NEAR experiment reported a thermal signal near Alpha Centauri A, a candidate planet detected through direct imaging, something called C1 or S1, depending on which paper you read. The signal was consistent with a planet, possibly a cold Neptune-class world orbiting in the habitable zone. The astronomy community responded with cautious interest and significant skepticism, because direct imaging of planets is extraordinarily difficult and false positives are common. You're looking for a dim point of light next to an intensely bright star, the equivalent of spotting a firefly next to a searchlight from across a city. In 2025, the James Webb Space Telescope followed up on this candidate with additional observations. The results strengthen the case for a real planet, but not the planet anyone was hoping for. The data suggested a cold giant planet, likely Neptune-class, orbiting Alpha Centauri A on a 2 to 3 year eccentric orbit. Not a rocky Earth analog. Not a temperate world with liquid water oceans. A gas giant, potentially interesting for planetary formation studies, utterly useless for real estate development. This is the astronomical equivalent of spending decades searching for office space. Finally finding a building in the right neighborhood at the right price, and discovering the available unit is a broom closet. The habitable zones around Alpha Centauri A and B still exist, of course. For A, roughly 1.2 to 1.8 AU, think somewhere between Earth and Mars. For B, roughly 0.7 to 1.2 AU, closer in. But B is dimmer, so the zone shifts inward. Dynamical studies suggest these orbits should be stable despite the binary nature of the system. Planets could form there. Planets could survive there for billions of years. We just haven't found any yet. Somewhere in the Alpha Centauri system, there might be Earth-like worlds. Statistically, there probably are, or were, or will be. But until we find them, verify them, and confirm they're not actively on fire, metaphorically or literally, the nearest star system remains less a destination and more an aspiration, a LinkedIn profile that says open to relocation while carefully omitting the section about hazard pay and equipment replacement costs. The swing sets keep arriving, the flares keep firing, and Patricia keeps filing reports that no one reads, documenting the growing gap between corporate optimism and astrophysical reality, one vaporized playground at a time. Well, my astronomically adjacent real estate speculators, we've reached the end of another quantum excursion through the cosmos. Today we've learned that in the multiverse of stellar neighborhoods, proximity is not the same as accessibility. Habitable zones are more suggestion than guarantee, and the phrase nearest star system does absolutely nothing to address the 4.5-year commute at light speed. We've discovered that Alpha Centauri, our cosmic next-door neighbor, the star system we've been gazing at longingly for centuries, consists of 2 reasonably well-behaved stars locked in an 80-year orbital dance, plus 1 temperamental red dwarf that treats planetary atmospheres the way an angry child treats sandcastles. We've learned that Proxima Centauri b sits in the habitable zone the way a marshmallow sits over a campfire, technically, briefly, and with increasingly concerning levels of combustion. And we've confirmed what Patricia from Employee Family Services learned at considerable expense. That habitable zone is an astronomical term of art, not a promise, and certainly not a warranty against regular equipment vaporization. The Alpha Centauri system remains our nearest stellar neighbor, the place we collectively imagine as humanity's Plan B, our escape hatch, our cosmic backup drive. We've emotionally invested in it despite knowing roughly as much about its actual planetary inventory as we know about what really happens in those all-hands meetings that could have been emails. We've projected our hopes onto it, built missions toward it, written science fiction about it, and named it in countless stories as the place we'll go when Earth finally cashes out its retirement fund. But hope, as it turns out, is not the same as infrastructure. Optimism is not the same as atmosphere. And being the closest option does not make you the best option. It just makes you the option people talk about when they don't want to acknowledge how truly, spectacularly far away everything else is. Want to explore more cosmic real estate disappointments and bureaucratic three-body problems? Visit us at multiverseemployeehandbook.com, where you'll find fascinating science news, and deep dives into stellar neighborhoods that look better in the brochure than in person. And if you've enjoyed today's expedition into proximity without promise, why not share it with a fellow optimist who still believes the nearest star system is somehow within reach? Perhaps you know someone who's ever looked at a job posting that said competitive salary and room for growth, and believed both statements simultaneously. Spread our signal like electromagnetic radiation from a temperamental red dwarf, enthusiastically, unexpectedly, and with potential for catastrophic consequences. This is your quantum coherent correspondent, reminding you that in the multiverses of stellar real estate, we're all just Patricia from facilities management, ordering swing sets, filing reports, watching the universe vaporize our carefully laid plans, and wondering whether habitable zone ever meant what we thought it meant, or if we've all just been reading the same misleading brochure for 400 years. Until next time, keep your expectations appropriately calibrated, your equipment properly shielded, and your definition of habitable flexible enough to accommodate regular stellar violence. The universe doesn't care about our org charts, but it does seem to have opinions about our playground equipment. And somewhere across 4.37 light-years of mostly empty space, 3 stars continue their gravitational dance, indifferent to our hopes, immune to our planning, and completely unaware that we've been staring at them for centuries, wondering if they might, someday, possibly, perhaps, become the backup plan we so desperately want them to be. Spoiler, they won't. But we'll keep looking anyway, because that's what we do.
Hello? Hey, I'm Rob Corrigan, the human who dreamt up the Multiverse Employee Handbook, because I can't stop marveling at how strange and wonderful the universe is, and how often it behaves like a very large company with confusing corporate policies. In a world increasingly run by AI, I think it matters to be clear about what's human-made and what's conjured by machine magic. So here's the straight-up rundown. The host, David, is a professional voice actor. The voice you hear has been digitized using 11 Labs voice cloning technology, with his blessing and excellent enunciation. The episode thumbnails are created with OpenArt's AI models. Music and sound effects come from Pixabay, composed by human artists. Everything else, the writing, the jokes, the research, is 100% me, human hands, human brain, and occasional human muttering. Thanks for listening, and for being a good human in an increasingly automated cosmos. And if you like this show and make it this far, it would really mean a lot to me if you shared it with a colleague, a friend, or anyone. It's really the best way to make podcasts like this grow, and I sincerely appreciate it.
Rob, do stop ringing after hours. The kettle's on and I'm halfway through a biscuit. Toodaloo.